Howdy rock buddies, Papa here. Top of the morning to you. Hope you're all doing fantastic. Today we are going to talk about Graywacke. Some people call it Graywacke. Pretty wacky name. And its metamorphic equivalent, Metagraywacke or Metagraywacke. I'm just going to call it Metagraywacke because Metagraywacke is just too wacky. Anyway, we're going to find out what it is, where you find it, when did it form, and why. So, if you like this video and it's useful, please subscribe. It helps me a lot. And so here we go. Graywacke / Metagraywacke. Many of our geological terms come from German language, and Graywacke is one of them. In German, it means a gray, earthy rock. Pretty appropriate, I would think. Graywacke is a turbidite deposit. So what the heck is a turbidite deposit, you may ask? A turbidite rock is a rock that has a matrix of sandstone, grayish sandstone, and embedded in that sandstone are all kinds of larger pieces of either minerals or rocks. You can have feldspar hunks, you can have quartz hunks, you can have granite hunks in there, and an important part of it is that these rock hunks are rough-edged. Turbidite deposits are formed when rocks of all sizes, from sand size up to maybe ping pong ball size, are rapidly washed into a very steep basin where they get all mixed up size-wise. These particles do not spend a lot of time in a stream. They are rapidly deposited, and so they don't have time to be rounded and smooth by the stream, hence they are rough on the edges and angular. Here are some examples of Graywacke and Metagraywacke for us to look at that came from my rock house. You can see there's usually the matrix of fine sand-sized grains with larger hunks embedded in them. The white hunks are feldspar. If it's a gray hunk, it's going to be quartz. And sometimes pieces of granite that have eroded from a granite pluton are included in these particles, and you can see that they are roughed edged. Here's a piece of river conglomerate for comparison to the Metagraywacke. Notice how rounded and smooth these pebbles are. It's because they spent a long time in a river that did not have a steep gradient, as opposed to the very steep erosion gradient of the Metagraywacke. Now, in all the examples that we've just looked at, the larger particles that are embedded in the sandstone are not that big. They're quite small. And for me, when I think about them, when I think about Graywacke and Metagraywacke, I think those larger clasts of rocks, pieces of angular rock, are going to be about the size of Abraham Lincoln's ear on a penny, plus or minus. And that's what I call Graywacke. You're fixing to see another group of turbidite sediments that have larger hunks embedded in them, and I call these specimens turbidite sandstone. And with turbidite sandstone, the large hunks are about as big or even bigger than Abe Lincoln's head on the penny. Here are some examples of what I call turbidite sandstone, with the larger hunks about the size of Abe Lincoln's head on the penny. Now, they are deposited in exactly the same way as Graywacke and Metagraywacke, and are deposited along with Graywacke and Metagraywacke. So why do I make a distinction here? I make this distinction personally to eliminate personal confusion, because if you look at, for example, the turbidite rock formations in Great Smoky Mountains National Park, there is a turbidite deposit called the Thunderhead Sandstone. And going by that name, you might suspect that it is a regular sandstone where all the grains or sand size, but in fact it is actually a turbidite deposit with clasts or big hunks that are as large or larger than Abraham Lincoln's head on the penny. So I call these turbidite sandstone to help me avoid that confusion between these turbidite deposits and regular sandstone, which is equigranular, which just means that the whole rock is made only of sand-sized grains. Okay, let's review. So if I see a rock formed via turbidite conditions that has the big hunks embedded in the matrix or about the size of Abe Lincoln's ear or smaller, I call that graywacke, or if it's been metamorphosed, metagraywacke. And if I see a turbidite deposit rock that has larger hunks that are the size of Abraham Lincoln's head or larger, I call that turbidite sandstone, to avoid confusing it with regular river sandstone or beach sandstone, which has sand grains all of equal size with no larger hunks in it. I know of 4 situations in which turbidite deposits such as graywacke and turbidite sandstone can form. So let's look at those one at a time. The first situation I know of is called the rift basin or rift graben. And graben is another one of those German terms that means a steep-sided basin. Here you see a picture of the rifting of supercontinent Rodinia, and we have 2 rift basins or grabens called West Graben and East Graben, and they are being filled up with turbidite deposits. To see these fantastic rift basin deposits, just go to Great Smoky Mountains National Park, and most of the rocks that you will be riding across are these turbidite deposits. Great Smoky Mountains National Park, you will find lots of metagraywacke and lots of metaturbidite sandstone. Second place that you find lots of graywacke and turbidite sandstone is on the Continental slope. This picture shows the southern tip of Florida with the continental shelf in light gray, and the red arrow is pointing to the place where the continental shelf drops off very steeply down to the deep and flat deep ocean basin. The steep drop-off is called the continental slope, and rock particles of all sizes are constantly being dumped down it in these underwater avalanches to create massive amounts of turbidite deposits like graywacke and turbidite sandstone. The third place you will find graywacke and turbidite sandstone is in a subduction melange. So what is that? This funky drawing shows what actually happened off the coast of Georgia during the tectonic orogeny. You can see ocean crust subducting down and to the left, creating a volcanic island, and in the process all kinds of geologic material is being scraped off the ocean crust and piled up against the island arc. That is called a subduction melange, and there's graywacke and turbidite sandstone in there as well as other rocks. Another subduction melange, and this is what actually happened off the coast of Virginia during the tectonic orogeny. In this case, the subduction zone was to the right or to the east, but it still piled up this huge melange containing lots of different rocks, including graywacke and turbidite sandstone. The fourth place you find graywacke, turbidite sandstone, and their metamorphic equivalents is in strike-slip faults like the Brevard Fault Zone. This is where one piece of terrain slides along against another piece of terrain. This causes intense metamorphism and deformation to these turbidite rocks, and they become what geologists call mylanites. So how do you remember that mylanites come from these strike-slip faults that move sideways against each other? Well, I remember it because I think the rocks are being slid about a mile a night. That's dorky, but it works. the classic example of a strike-slip fault is called the Brevard Fault Zone. It runs from eastern Alabama all the way up at least to the North Carolina-Virginia border and probably through most of Virginia too. And it's a strike-slip fault that has played a huge part in the development of the Appalachian Mountains. Okay, most excellent rock buddies, that's the story on our turbidite deposits called Graywacke and Turbidite sandstone. I hope that was helpful. Please subscribe if it was. And this is Papa wishing all you great people happy rock hunting. Papa out.